Welcome back to Djji Tutorials. Today we are diving into simplifying radicals and a review of laws of exponents. Chapter 1. Simplifying radicals. To simplify radicals with fractions, you should separate the radical into the square root of the numerator and the square root of the denominator. Simplify each radical separately, and then rationalize the denominator if necessary. Steps 1. Separate the fraction under the radical. Rewrite the radical of a fraction as the product of two radicals, one for the numerator and one for the denominator. For example, the square root of 16 over 25 becomes the square root of 16 divided by the square root of 25. 2. Simplify each radical. Simplify each radical separately, looking for perfect squares, or cubes, etc., depending on the index of the radical within the radicand. The square root of 16 is 4 and the square root of 25 is 5. 3. Combine and simplify. If the denominator still contains a radical, which it usually will, you'll need to rationalize it. Multiply both the numerator and denominator of the fraction by the radical in the denominator to eliminate the radical from the denominator. In our example, 4/5 is already simplified. Example. Simplify the square root of 4 over 9. 1. Separate. The square root of 4 over 9 equals the square root of 4 divided by the square root of 9. 2. Simplified, the square root of 4 is 2, and the square root of 9 is 3. 3. Combined, the simplified form is 2/3. When a radical remains in the denominator, you need to eliminate it. Multiply both the numerator and denominator by the radical in the denominator. This will result in a perfect square under the radical in the denominator, which can then be simplified. Simplify 1 over the square root of 2. First, multiply by radical over radical. 1 over the square root of 2 times the square root of 2 over the square root of 2 equals the square root of 2 over 2. The simplified form is the square root of 2 over 2. When multiplying terms with the same base, you keep the base and add the exponents. This rule is often called the product rule of exponents. For example, when multiplying x squared and x cubed, the base is x, and the exponents are 2 and 3. Adding these gives x raised to the 2 plus 3 power, which equals x to the 5th power. Here's a more detailed explanation. The rule m times n equals a to the power of m plus n, where a is the common base and m and n are the exponents. Examples. First, 2 cubed times 2 squared. The base is 2. The exponents are 3 and 2. Add the exponents. 2 cubed times 2 squared equals 2 to the power of 3 plus 2, which is 2 to the power of 5, and that's 32. Next, x to the power of 4 times x to the power of 3. The base is x. The exponents are 4 and 3. Add the exponents. X to the power of 4 times x to the power of 3 equals x to the power of 4 plus 3, which is x to the power of 7. Finally, 3y squared times 2y. Multiply the coefficients. 3 times 2 equals 6. The base is y. The exponents are 2 and 1, since y is y to the power of 1. Add the exponents. 3y squared times 2y equals 6i to the power of 2 plus 1, which is 6i cubed. In essence, multiplying terms with the same base is a shortcut for expanding the exponents and then combining the terms. For example, x squared means x times x and x cubed means x times x times x. When you multiply x squared times x cubed, you have x times x times x times x times x, which simplifies to x to the power of 5. When dividing terms with the same base, you subtract the exponents while keeping the base the same. This rule, known as the quotient property of exponents, applies to both whole number and fractional exponents. Here's a more detailed explanation. The general rule is x to the m divided by x to the n equals x to the power of m minus n. This means when dividing two expressions with the same base, x in this case, you keep the base the same and subtract the exponent in the denominator, n, from the exponent in the numerator, em. Let's say we have the expression 2 to the 5th divided by 2 to the 3rd. Applying the rule, we keep the base 2 and subtract the exponents 5 minus 3. This simplifies to 2 squared, which equals 4. Alright, let's dive into an example with variables. Let's say we have x to the power of 7 divided by x to the power of 3. We keep the base, which is x, and subtract the exponents, so 7 minus 3. This simplifies to x to the power of 4. Now let's talk about why this works. Dividing is essentially the opposite of multiplication. When multiplying exponents with the same base, you add the exponents. Therefore, when dividing, you subtract the exponents. Simple, right? Here's an important note to remember. This rule only applies when the bases are the same. If the bases are different, you cannot simply subtract the exponents. Keep that in mind as you work through these problems. When a power is raised to another power, you multiply the exponents and keep the base the same. This is also known as the power of a power rule. For example, x cubed squared, where x cubed is the first power and 2 is the second power, becomes x to the power of 3 times 2, which is x to the power of 6. Explanation: the power of a power rule. If you have an expression like a to the power of m to the power of n, where a is the base, m is the first exponent, and n is the second exponent, you simplify it by multiplying the exponents. A to the power of m to the power of n equals a to the power of m times n. Consider the expression 3 squared cubed, where 3 is the base, 2 is the first exponent, and 3 is the second exponent. Applying the power of a power rule, you get 3 squared to the power of 3 equals 3 to the power of 6. You can think of it as repeatedly multiplying the base by itself as many times as indicated by the second exponent. For example, x cubed squared means x cubed times x cubed, which equals x times x times x times x times x times x, and that equals x to the power of 6. When raising a power to another power, always multiply the exponents and keep the original base. Please share with your classmates. Don't forget to like and subscribe. See you in our next session.